Okay, so let's look at the probability question from EC paper, Electronics and Communication, and from 2023 year, right? And for other PYQ, like for the other years, you will find the link in the description, so you can go through that. So the first question we have is 36. So this is the first question, right? So this question, you can say that this question is from the transformation, right? So what we have given, that a random variable x distributed normally and with the mean 0 and with the variance 1. So this x is the normal distribution, right? And with the mean 0 and with the variance 1, right? Undergoes the transformation y is equals to hx. So we have given this transformation y is equals to hx, right? The form of probability density function of y is, so what we have been asked, that what is the probability density function of the random variable y, right? And okay, so first of all, let's look at this transformation that we have given. If you look, then you see that this x is a random variable, x is a random variable, and it is normally distributed, right? And if you look at this y varies from -1 to 0, right? So y is from -1 to 0, and this x is taking the complete, right, real line. You can say that x is from -infinity to +infinity, and this should be this the complete probability of x should be compressed within this interval, within this -1 to +1 of y, right? So so let's, so this is x, the PDF of x is this, right? So it is normally distributed and with the mean 0 and with the variance 1, right? So this is x, and y will be from, you can say that from -1 to 1, right? And if you see that from x is equals to -1 to 1, y is 0, right? So y is 0. So for x, so for x is equals to -1 to 1, y is 0. So that means this probability of this probability will be concentrated at y is equals to 0, right? So we will have some impulse here, and this, the weightage of this impulse would be the this probability area under this -1 to 1, right? So for y is equals to 0. And now let's look at this from x is equals to 1 to 2. This you can write y is equals to x minus 1, right? So for x is equals to 1 to 2, y is varying from 0 to 1, right? So y is varying from 0 to 1, and for this is y is equals to x minus 1. That means what does it mean? That we will have this x is normally distributed, right? So this x minus 1 will be also normally distributed, right? But with the mean shifted to 1, and y is in this case from 0 to 1. So if we take from y 0 to 1, right, then we will have some, because this x is normally distributed, right, then this x minus 1 is also going to be normally distributed, but with the shifted mean. And so y will be normally distributed from 0 to 1, right? And so from 0 to 1 we will preserve the distribution, right? So maybe, I don't know, maybe something like this we will get, I don't know. And same thing for y, for x is equals to -1 to 2, y will be 0 to -1. So we will preserve the normal distribution. So this will maybe look like something like that. So we can calculate that, but let's assume that, because we don't have to calculate the exact PDF, right? Okay, so we have calculated from here to here, right? Now we are left with this area, right? This part and this part. See, and if you see that for x greater than 2, we have y is equals to, y is 1, right? So this probability will get mapped at y is equals to 1. So here we will have again a impulse, and similar for this part. So here we will have again a impulse, right? So let's call, so we will have 3 impulses at y is equals to 0, and some at y is equals to 1, and y is equals to -1, and we will have some function. So you can call it gy, right? And the weight of these impulse will be some this probability, right? So weight of this will be this probability, and weight of this area will be this, weight of this impulse will be this probability, the area under this, right? So we can say that we will have some A times P times C, right? So according to that, if you look, the correct option is B, right? Okay, now let's look. Let me see. So at impulse 1 and minus 1 1 and 0, and we have some gy, and we have given this gy as gy is a piecewise continuous function, and abc are non-zero constant, so we are good. Okay, now let's look at one more question. Okay, so this question is more oriented towards, like, you can say the communication part, but let's look at this. So what we have been asked, that the frequency of occurrence of 8 symbols A to H is shown in the table below. So these are the frequency of occurrence. So maybe some source is generating some symbols, right? And we have got this A, B, C, D, E, F, and with the probability this, right? So what we have been asked, that it is some symbol is chosen, and it is determined by asking a series of yes or no questions, which are assumed to be truthfully answered. Okay, so we have to choose a symbol from this. So maybe and how the rule of choosing the symbol is, you can ask a question, and that question could have the answer yes and no, either it could be yes or no, and also it is given that the answer you will get is the true, right? But that means you are asking a question, and that person will tell you a truth answer, right? If you ask that the given symbol is from A to D or E to F, so your question could be that this symbol belongs to this part or this part, right? So that person will tell you a correct answer. He will tell you, right, it belongs from to the right side, right? So you will be neglecting this part, and your search will be in this part, right? So that is what it means here in the question, that a symbol is chosen, and it is determined by asking a series of questions yes or no, which are assumed to be truthfully answered. The average number of questions. So with this given probability, what we have been asked, that the average number of questions we when asked in most efficient sequence to determine the chosen symbol is. So like what would be the average number of questions that you will ask to identify a symbol, right? The overall point is that here you will have to find the entropy, right? So how you can find is, we have given the probability, right? So it will be 1 divided by log 1 divided by probability of this A, so 1 divided by 1 divided by 2, so here will be 2. Similarly for all, so 1 divided by 4 log 4, and plus 1 divided by 8 log 8, for you will have to do for all, and here we will have at the end log 1 divided by 128 log 128. Now it will be 1 divided by 2 into 1 plus 1 divided by 4 into 2 plus 1 divided by 8 into 3 plus 1 divided by 16 into 4 plus 1 divided by 32 into 5 plus 1 divided by 64 into 6 plus 1 divided by 128 into 7 plus 1 7, right? Now you do the calculation, you will get your answer, and it will be 1.983, something like that. Okay, that was the 2 questions from 2023 PC paper in the probability.